guys. I hope you guys having fun during this weekend, and to add more flavor to your fun, I have brought some excellent questions here. So the questions are from engineering mechanics. It's all about moment and forces. Let's do the questions. The first question is asking asking us determine the tension in the cables in order to support the 100 kilogram crate in the equilibrium position shown. So they have given the diagram here. So if you whenever see a picture like this, x y c components, the first thing you have to do is just name the components, like what is the distance, and just put it in one side. So that will be helpful to solve the question. So that's what I'm going to do now. So they have given a b c. Wait a minute. Okay, A, B, C, A, B, C, D. So we have 4 points here. First I'm taking A. A is in the origin, so it's going to be 0, 0, 0. And B is, if you see, B is 2.5 distance in the x-axis, but it's positive. Because how do I know if it's positive? Because they have labeled x in this side. So Y in this side and C in this side. So wherever the label is, that's we consider that side as positive. So therefore, this A is in B, 2.5 is positive. 2.45 is positive, and the distance from y distance is 0 because it's along the x-axis. So y distance is 0, and c, there's no height, so it's c also 0. And c part, the y distance is 2 meter, but it along the y-axis, therefore there's no x-axis. But we have to be careful in this place because this is opposite to the y they have labeled, so it means it's negative. So it's negative 2, 0, negative 2. There's no height, so the height is 0. And the d part is from x-axis, how long it is. If you see here, they have labeled 2 meters, so it's 2 meter distance from the x-axis. Oh, it's 2 meter distance from x-axis, so it's going to be 2 comma, and y also 2, as they labeled here. Y also 2, and c, it's 1 meter height, so it's going to be 1. So 2 to 1 is the d. So now so the question is determine the tension in each cable in order to support the 100 kilogram crate in the equilibrium position, so on. So they have asked equilibrium. So in order to do that, I have to find force. So to find the force, first of all, I have to know unit vectors. So in this case, we have to calculate the unit vectors from the A. So first of all, let's calculate AB. So if I calculate UAB, UAB is going to be RAB, and magnitude of RAB over magnitude of RAB, which is going to be equal to um, 2.5 RAB. So B minus A. If you see UAB, it means from the last letter is B, so A is coming first, so it should be B minus A. So in this case, it's 2.5 minus 0, 2.5 minus 0 I, and 0 minus 0 is 0, 0 minus 0, so 0j, 0k, 0k, and over uh, all the other values are 0, only x values, I value is 2.5. So I have to just simply 2.5 square root. So whatever the square root of square is going to be, same number. So it's going to be 2.5 I over 2.5. So which is simply going to become just an I. So UAB is just an I. And let's do the UBC now. UBC is going to be RAB over RBC over RBC magnitude. RBC magnitude. So in this case, we know all the other x and z values are 0. So I just gonna put 0, and z value is negative 2, negative 2j, and all the others are 0. And in the bottom we multiply 0 to square, we square negative 2 and square root it. So negative 2 square root is going to be positive 2. So negative 2j divided by 2, it's going to be negative j. So that's my UBC. Now I have to find UBD. UBD is going to be equal to UBD is going to be equal to 2. Okay, they have given what is 2i. So 2 minus 0, 2 minus 0 to 1 minus 0 is going to be same number, 2i plus 2j plus, and we have to look the diagram carefully. Did we miss any minus? Okay, so this is opposite to this distance. D of distance is opposite to the x-axis, so it's negative 2, and y is positive and z is positive, so I have to put negative 2 for the uh, x-axis, so it's going to be negative, and all of the others are positive. 1k over square root of negative 2 square plus 2 square plus 1 square, so it's going to be 9. So therefore it's going to be negative 2i plus 2j k over square root of 9 is 3. So this is my UBD. From this one I can find the I can find the FP, like FAB, FPC, FPD. So to do that I have to simply multiply by each force. Okay, here we go. Okay, so now I'm going to separate this one. It's going to be like this. So if FAB is going to be what? FAB is going to be UAB, let's say it's f of this is, how can I call it, let's see, I call this FAB. So if it's FAB, the answer is going to be unit vectors times this number. Unit vector is this number, so I have to multiply the force. It's going to be like FB times something like FB times unit vectors. So it's going to be, the final answer is going to be unit vectors. It's going to be FABI, because only I is remaining for FAB. For same like that for the FBC. FBC is going to be negative 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 FBCJ, because J is negative, so negative FBCJ. And for FBD it's gonna be 2 over 3 FBDI, negative 2 over 3 FBDI, and plus 2 over 3 FBDJ, and plus 1 over 3 FBDK. So this is my FBD. Now what I'm going to do is, this since this is equilibrium, I can, if I add all the forces together, it should give us 0. So that's how it works. So FAB, let's say sigma F is equal to 0. Sigma F is equal to 0. I'm going to add all the forces. So FAB plus FBC plus FBD, plus we have to make sure whether there's any weight right here. So there's a weight here, and weight is given, it's 100 kilograms, so we have to add that weight too. So plus the weight is equal to 0. Now simply I have to represent all the values. For FAB I'm going to put FABI, and for FBC minus FBCJ, and for FBD I'm going to put minus 2 over 3 FBDI plus 2 over 3 FBDGA, plus 1 over 3 FBDK. Since I have these values, so what I have to do is, and I shouldn't forget the weight, guys. Weight is one of the important factor right here. So it's 100 kilogram is given, so I have to, since this is 100 kilogram, I have to convert into Newton. So convert into Newton, I have to multiply this by 9.8. It's going to be 980 Newton. So it's going to be negative because it's acting downward, right? So negative 980 Newton. Now I have to separate all the I, j, k because I is in the x-axis, j is in the y-axis, k is in the c-axis, so they will never add together. So I have to separate and add it. So I have to add I with I, j with j, and k with k. Since we have FABI and minus 2 over 3 FBDI, I'm going to put it together. So it's going to be FABI minus 2 over 3 FBDI. So I put it in one place and plus, then I'm going to add the J, here FBCJ, and here one FP 2 over 3 FPDJ. So 2 over 3 FPDJ minus FPCJ. So I put both of them together, and since we only have one K, the K is in the C direction, but the weight also C direction because it's acting vertically downward. So I have to add this weight with the K. It's going to be 1 over 3 FBD K minus 980 Newton. So 980, and all of them are going to be equal to 0. Now what I can say is I can simply equalize each of the bracket. I put it right here. I can equalize each of the bracket for equal to 0. So first of all, if you look at this one is a FABI, FPDI, two unknown variables, but for the FPK, only one unknown. So if I equalize that to 0, I can simplify the FPK. So let's do that. So 1 over 3 FPK minus 980 is equal to 0. So FPK is equal to 980 multiplied by 3. So if I multiply, I have to get what I have to use the calculator right now. So let's see what's the number we are getting. 980 times 3, which is 2940. 2940. So I got the FPK, and it's positive, and the unit is Newton. FPK is 2940 Newton, and from this I can find the FBD and FBC, because let's say in which equation I can equalize. So let's say, okay, FBD, this is FBDK. So instead of I'm putting FBD, this is equal to FBD, right? So FBD is equal to 2940. So if I use that FBD for this one, let's say this equation J, I'm taking the J equation right now. So if I take the J equation, 2 over 3 FBD minus FBC J is equal to 0. J is equal to 0. So I can tell this 2 over 3 FBD is equal to FBC. So I can simply multiply. I have found the FBD here, right? It's 2940. So if I put 2 over 3 times 2940, it's going to give me FBC. Let's calculate the number. So 2940 multiplied by 2 divided by 3. It's going to give me 1960. 1960 Newton. So FBC is equal to 1960 Newton. So from this one I can find the FAB, because FAB is the same thing. It's a FABI minus 2 over 3 FPDI is equal to 0, then if you see FAB is equal to, like, if minus, then if I took the other side of the equal, it's going to become plus, right? So FAB is going to be equal to 2 over 3 FBD. So here if you see for the FBC, I have done the same thing, because FBC is also equal to 2 over 3 FBD. So if FAB also same thing, then I can just put the same number. So this is going to be equal to FAB. So FAB and AFPC are same number, 1960, and FPD is 2940. I think that's the question. The question is asking what? Determine the tension in the cables in order to support the 100 kV gate in the equilibrium position shown. So we have done the question. So let's do the second question. The second question is asking, determine the moment of each of the three forces about the point A. So from this point A, I have to calculate all of the moments. So we have three forces right here. F1. F1 is equal to 250 Newton. 250 Newton, and the distance is 250. But we have to be careful. In this case, we have to be careful, because 250 Newton along 30 degree. So it means 250 Newton cos 30. 250 cos 30 is the direction. Or you can say sine 60, it's going to be same thing. 250 cos 30 Newton. And F2 is going to be, because we are doing it vertically, so usually most people do sine 60, it's the same thing, cos 30 or sine 60, same thing. And for this one, from vertical is making 60 degrees, so you can say it's 300 sine 60 or 300 cos 30. I like to keep it all same, so it's going to be 300 cos 30. And we have to be careful about the sign. So because if it's acting clockwise, it's negative. If it's acting anti-clockwise, it's positive. So in this case, we have to look at the object. So the arrow is shown from the top side of the object to it's coming toward the object. So it means it's going to pull that object down. So it means acting clockwise. Therefore, it's negative. If it's something acting clockwise, if it's pulling the object down, it means it's negative. So it's going to be negative. Both of them are F1 and F2 is negative, and I have to calculate the F3 right now. So F3, in this case F3, it's 500 Newton. It's not shown in the picture, but it's 500 Newton acting vertically and horizontally, and they have given the two directions. Vertical is 4 and hypotenuse is 5. So therefore I had to find the adjacent. Adjacent, again I can use a Pythagorean theorem right here. 5 square minus 4 square. It's going to give me the adjacent. 5 square is 25. 25 minus 16 is equal to 9. 9 root 9 is equal to 3. So 3 is going to be my adjacent. And from this I can find vertical uh, vertical vertical force and horizontal force. To find the vertical, I had to do sine theta. So F3 sine theta is going to be vertical. F3x sine theta. So sine theta is going to be what? Opposite over hypotenuse. So opposite is, so whenever you see something like this, opposite is going to be always the y-axis. So y-axis is going to be the opposite, and x-axis is going to be the adjacent. So in this case, y-axis is 4. They have given y-axis is 4. So F3 is given it's 500 Newton. So I had to multiply 500 Newton by y-axis is 4. 4 over hypotenuse 5. So if I multiply, I will get 100 times 4, 400. 400 for this one. And if I calculate the f3x sine theta, f3x cos theta, to calculate the vertical force, right? Vertical force. So f3x cos theta is going to be adjacent over hypotenuse. So adjacent is, we know it's 3, and 500 times 3 over 5. So it's 1500 over 5, it's going to be 300. So this is my x and y components, and let's put it here, 300. f3x is, so let's put x, f3x is 300, f3y is 400. Now this is not about the force. The question is all about determine the moment. So if they say something like moment, we have to multiply the force by distance. So distance for, I have to take care of the distance for each other. So for the f1 it's 2 meter distance, 2 meter distance, and for the f2 it's 2 plus 3, 5 meter distance. For f3x and f3y it's same distance, it's 4 4 meter distance. So d is equal 4, d is equal 4. Actually for f, wait a minute, because this is f3x is horizontal. We shouldn't forget that. So for horizontal it's from the origin, right? So it's going to be 2 plus 3, 5. So 5 meters is the distance for the f3x. For the f3y it's 4. So now what I have to do is I have to calculate the moment for each of them. So it's going to be, for the first one, f1 is going to be negative 250 cos 30. Cos 30 is what? Root 3 by 2. Root 3 by 2 times 2 is going to be negative 250 root 3. And same thing for this one, like it's f2 minus 300 times cos 30. So cos 30 is root 3 by 2. So minus 300 become minus 150 times 5 is going to be 150 times 5 is going to be 750. f2 negative 750 root 3, and f3x is going to be, and both of them are clockwise, and f3x is going to be f3 is 5 times 300 is going to 1500, and f3y is going to be f3x is going to be 1600. 400 times 4 is 1600, right? Wait a minute, 1500, this is 1600. 1000, 1500, 1600. Oh, yeah, 1500, 1600. And now we have to take care of the direction. So let's see. So if you imagine for this one, if it's acting horizontally, it means this thing pulling the object upside. So it means the horizontal component is going to be counterclockwise, because if something is lifting the object upside, it means it's against, like that's mean that pulling up mean is counterclockwise. So this is going to be counterclockwise, and this is clockwise. Y direction is always pulling down, so it's clockwise. So in this case, f3x and f3y, same thing. So now we have to forget about the xy components, because when it comes to movement, we only have two directions. One is clockwise or counterclockwise. Now since we have f3x is clockwise and f3y is counterclockwise, I can simply deduct both. Like I can deduct 1500 minus 1600, because 1500 is going to be positive direction, counterclockwise is positive and clockwise is negative. So 1500 minus 1600, so f3 is going to be minus 100 Newton. This is my final answer for this question. And the next question, the next so let's make sure we are done. Determine, the second question is determine the movement of each of the three forces about the point A. So we have found each of the forces, and that's it. Let's move to the next question. So next question is asking determine the moment of force F about the door hinge at B, express the result to you as a Cartesian vector, and also find the moment MB value and in the projection around line BA. So we have two different questions right here. So since if we find a picture like this, first of all we have to note all the points. So first of all, they have given A, B, C, D, A, B, C, D. That's all they have given. So let's note the points. A, A is gonna be what? A is how many distance? Like 5 feet, 6.5 feet from the x-axis. So it's going to be negative A of 6.5 because when they label, if they label x, y, z, that's considered as positive side, and this is opposite to that side. Therefore, this negative 6.5 along with the x-axis, negative 6.5 and comma negative 3 in the y-axis because it's opposite to the y-axis, right? So negative 3 y, and it's not there's no height for this, therefore z is 0. And b, if I note down the b is 3 feet away, like for the x value it's 1.5 feet away, so it's going to be negative 1.5, negative 1.5, and 3 feet away from the y-axis, so it's negative 3, and there's no height for b, so this c is 0. For the c part, for the c part it's along with the y-axis, therefore there's no x for this. But for the y, so x is 0, but for the y it's going to be negative 1.5 plus, if you see it's a 45-degree lifted, and the distance is what? The distance is 4 feet, so it's going to be 4 cos 45, 4 cos 45, so plus 4 cos 45. And for the z it's going to be 45 degree. I have to just count the vertical distance, so it's 45 degree up and 4 feet long, so it's going to be 4 sine 45, and it's positive. And then the d part, is along with the x-axis, and it's 5 feet opposite to the x direction, therefore it's negative 5, and there's no y, there's no z, so it's just negative 5, negative 5 0 0. So this is my d. So now I'm going to go ahead and read the question again to understand it more. Determine the moment of force F about the door hinge at B and express the result as a Cartesian vector. Okay, so this is the question. Let's see what we can do with the number we have got right here. So what I can do is I can simply okay, let's find the unit vector. Since if we got something like this, it's better to find the unit vector first and then figure it out what we can do about that. So first of all, I'm going to do RBC. If I do RBC, but for this one, if you look at the picture, UCD is the main picture because the force is going from the C to D. So if I had to definitely, and force is given for that, so I had to definitely calculate the unit vector of UCD. So let's calculate that one first. UCD is equal to, so if you see number something like that, UCD, so D is the last one, so I have to deduct C from D. So it's going to be minus 5 minus 0 I plus uh, negative, and 0 0 minus minus, so it's going to be minus minus become plus, and 1.5 plus cos 45. So 1.5 plus 4 cos 45. Cos 45 is root 3 by 1 over root 2. So 4 over root 2 plus 4 over root 2. 4 over root 2. And the next part is sine 45. So 0 minus sine 45. So this is going to become minus sine 45. Sine 45 also 1 over root 2. So it's 4 over root 2. Therefore, the bottom is going to be simply the square of these three numbers. So this is minus 5 square root of these numbers. So minus 5 square, I had to calculate 1.5 plus 4 over root 2. 1.5 plus 4 over root 2 whole square minus 4 over root 2 square. So since the calculator in the internet are complicating, I am using my own calculator to calculate this thing. So let's say, so 1.5 plus 4 over root 2, 4 over root 2, which is going to give me 4.33. So 4.33 minus 5i plus 4.33j, this is j, this is k, so 4.33j and minus 4 over root 2 k. So 4 divided by root 2 is equal to 2.83 k. 2.83 k. Now what I have to do is I have to simply square these numbers. Minus 5 square plus 4.33 square plus actually it's minus, but if I square minus it's going to become plus. Let's say minus 2.83 square. So if I square that number, it's going to become 5 square plus 4.33 square plus 2.83 square. It's going to equal to 51.76. So it's going to be 5 minus 5i plus 4.33j minus 2.83k 83k over square root of 51.76. So this is gonna be my UCD. Now we have to divide this by each one. So I'm going to do it all together. So let's calculate the FCD. So if I want to calculate the FCD, they have the given the force in the picture. It's how many lb? 80 lb. So I have to multiply 80 lb with this UCD. If I multiply, I will get the force. So let's do that. 80 times. So first to calculate this, divide this each numbers. Let's calculate square root of 51.76 is equal to what? Square root of 51.76 is equal to 7.2. So negative 5i over 7.2 plus 4.33 over 7.2 j over 7.2 minus 2.83 over 7.2. So these are my three vectors. So to find the force, I have to simply multiply all three by 80. So if I multiply, what I will get? Let's see. So first of all, let's find the decimal number for this. Negative 5 divided by 7 point what? Negative 5. Okay, 5 divided by 7.2 is equal to 0 0.69. 0 0.69i, and 4.33 divided by 7.2, 4.33 4.33 divided by 7.2 is equal to 0 0.60 j, and plus the 2.83 minus, it's minus, so we have to be careful about the sign, guys, because if one sign is messed up, everything is gone. So 2.83 divided by 7.2, 2.83 divided by 7.2, so 0.39 k, 0.39 k. So this is my value for the Jew. So now what I'm going to do is I'm going to multiply this number by 80. So if I multiply these numbers by 80, that's my force. So it's 0.69 I plus 0.60 j minus 0.39 k. So let's multiply. So 80 times 0.69 is equal to 80 times 0.69 is equal to 55.2 I, 55.2 I plus 80 times 0.6, 80 times 0.6 is equal to 48. So 48j minus 0.39 times of 80 is equal to what? 31.2 k. So 31.2 k. This is my final answer for the force. But we are not done yet. So they are asking express the result as a Cartesian vector. Also find the moment MB value and projection around the line BA. So now we have to find the MB, moment MB. So in order to find that, I can simply multiply this force, whatever the force I got, I can multiply this force by RBC or RBD, because if you look at the picture, RBC, so where's BC? B is B is right here and C is right here, and we have found the CD. So if it's along with the CD, we can find the moment if we calculate RBC, RCD. If I simply multiply with this force, it's going to give me the turn. So that's what we have to do, RBC or RBD, whatever you like. So first of all, we have to calculate RBC. So in order to calculate it, I have to simply like let's subtract, simply subtract each other. So I have to subtract B from C. Oh, I have to subtract C from B. That's how I find RBC. So let's do that. So RBC is going to be equal to C from B. So 0 minus, no, C minus B. So C is 0. Okay, C minus B. So 0 minus 1.5 is going to be 1.5. 1.5 plus, and negative 1.5 plus 4 cos 45, negative 1.5 plus 4 cos 45 minus minus 3. So minus 3 is become plus 3, and plus 4 cos 45 minus 0. So it's going to be 4 cos 45. So this is going to be my RBC, and if I calculate that, it's going to be 1.5 I, and negative 2.8 j, negative 8 2.8 j, and 2.8 plus 2.8 k. So what I have to do is to get the MB is the question, right? Let's see. uh, yeah, MB is the question. So in order to calculate the MB, I have to simply multiply RBC by the F we have found already. So RBC times F. So if I multiply, I will get negative 40. Wait a minute. Okay, guys. So this is negative, right? This value we shouldn't forget the negative here. So this is negative. So if I calculate R RBC is going to be negative 48.8. No, it's going to be 82 point. It's 82 point. We multiply these two. It's going to be 82.9 I minus 96.8 J and minus 52.8 K. 2.8 K. So this is how we do this question. So let's move to the next question. Next question is asking determine the tension in each cable for the equilibrium. So let's see what we can do right here. So each cable, so if you see the picture, the A is on the middle, so that's gonna be assigning the equilibrium. So A times, and we have three separate lines here. It's D, AD, AB, AC. So I have to calculate unit vector for each of them, then only I can find tension for each, right? So let's calculate it. First of all, let's put the points. Let's start with A. So if I put A is like 5 meter high, but otherwise it's in the origin. So therefore, Z is going to be 5, and it's in the positive direction, so it's positive 5, and others are 0. So 0, 0, 5. A is 0, 0, 5, and for the B it's going to be 4 meter distance from x-axis. So it's going to be 4 meter distance from y-axis, so it's going to be 4, and there's no height for B, so therefore it's 0. B 4 4 0, and C is like, it's how many meter? Okay, from x-axis is 2 meter in the negative direction, so negative 2, and 3 meter in the y-axis, that's positive, and there's no height, so it's 0. And for the D, it's 5 meter from the x-axis. It's 4 meter distance in the negative side, so it's going to be negative 4, and 5 meter distance in the y-axis is in the negative direction, so the negative 5, and there's no height, it's 0. So let's calculate each value. So UAB is going to be equal to UAB mean B minus A. So B minus A, 4 minus 0 is 4. uh, 4 minus 0 is 4i, so 4i plus 4 minus 0 is 4j, so 4j, and 0 minus 5 is negative 5, okay, over, so I have to square root of all the values to find the magnitude of RAB. So it's going to be 4 square plus 4 square plus minus 5 square. Minus 5 square will become positive, because whatever negative value square is going to be positive number. So 4 square is 16, 4 square is 16, 16 plus 6 is 32, 32 plus 25 is going to be 57. So it's square root of 57. Square root of 57 UAB. So that's my UAB, and let's calculate UBC. UB, no, UB, not UBC, because we have to calculate everything along with the A, because this those lines are connected with A, so I have to calculate everything with along with A. So it's going to be UAC. UAC is going to be C minus A. So C is negative 2, negative 2 minus 0 is going to be negative 2I, and 3 minus 0 is going to be 3, 3J, and 0 minus 5 is going to be minus 5K, over 2 square is going to be 4, 3 square is going to be 9, 9 plus 4 is 13, 13 plus 5 square 25, so 25 plus 13 is what? 25 plus 13 is 38. Let's calculate. 2 square is 4, 3 square is 9, 9 plus 4 is 13, 13 plus 25 is equal to 20, 38, okay. Square root of 38 divided by square root of 38. And this is the answer for UAC. And now I have to calculate UAD. UAD is going to be equal to D minus A is going to be negative 4I minus negative 5 minus 0 is going to be negative 5, negative 5J, and 0 minus 5 is minus 5K. So minus 5K over, so now I have to find the magnitude of the RAD. It's going to be negative 4 square 16, negative 5 square 25, 25 plus 16 is going to be 31 and 41. So 41 plus 25 is going to be 66. So square root of 66. Let's calculate again. 4 square is going to be 16, 5 square is 25, 25 plus 16 is 41, 41 plus 25 is equal to 41 plus 25 66. Yeah, so it's square root of 66, square root of 66. And since this is in the equilibrium, I can simply add everything and say it's equal. And first of all, I have to find the forces for each of them. So force of UAB is going to be what? It's going to be FAB times UAB, like FB, FAB, whatever the value you pick. So FAB times UAB, and F, UAC is going to be FAC is going to be FAC times UAC, and FAD is going to be FAD times UAD. So this is going to be my value. And now what do we have to do? We can simply say this is in the equilibrium, so I can add it all, or add all of them together and say it's equal to 0. And we shouldn't forget that there's an 800 Newton acting upward, so it's going to be in the Z direction. I have to add that one too. So let's say FAB plus FA, so let's say sigma F is equal to 0, and FAB plus FAC plus FAD is equal to 0, FAD and plus that 800 Newton equal to 0. Now I have to put everything, everything. So it's going to be let's put the XYZ components, because it's going to be a separate thing, because I can't add I with J, I can't add J with K, because all of them are like I is in the x-axis, J is in the y-axis, and K is in the z-axis. So what I am going to do is I'm going to form 3 separate equations for x, y, z, and add them and equalize to 0. So first of all, I'm gonna form a x component equation. It's going to be x direction, so sigma x is equal to 0. So in this case, I'm going to get all the I values and add it. So for the first one, UAB, it's going to be FAB times 4I over square root of 57, plus the second one is going to be FAC times negative 2I over square root of 38, and the third one is going to be uh, FAD times negative 4i over square root of 66, negative 4i over square root of 66. So this is equal to 0, and if I form second equation for the y-axis, so sigma y is equal to 0. If I form the equation for y-axis, it's gonna be, I have to add all the j values. So first of all, I add FAB times 4 over square root of 57, 4j over square root of 57 plus 3j over square root of 38, like FAC times 3 over 3, FAC times 3j over square root of 38 plus, and it's actually minus, so the minus sign is there. I had to put minus here. It's going to be minus FAD times FAD times FAD times 5j over square root of 66, 5j over square root of 66 is equal to 0. And now I am going to take the z component, and sigma is equal to 0. Now I have to put all the k values here. So if I put the k values, it's going to be, first of all, it's going to be FAB times negative 5 over 57, 5k over 57, square root of 57, and plus negative 5k over square root of 38 multiplied by FAC. So FAC times negative 5k over square root of 38, and the third one is going to be FAD times negative 5k over square root of 66. So this is my third value one, but we have to add one more thing, guys, because this is in the z direction. So in the z direction, the force 800 newton, you have seen this 800 newton, so it's acting vertically upward, so it means it's in the z direction. So when I put components for z direction, I have to add this 800 newton too. So it's going to be plus 800 newton. So now we can solve all the three equations. We can multiply and subtract and add subtract all together. Like if you see all the z values are same, so you can simply, if you subtract, each will cancel, and for some of them, for if you look at this, like look at the first equation, FAC time negative 2, and it's a square root of 38, and for the second equation, it's FAC times 3 over negative square root of 38. So it's both equal components. So you can simply multiply and add and subtract. You can cancel each equation, because if I start to solve this one, it will take another 30 minutes to solve it. So I'm just going to give you simple values. You can try it for yourself. So I give you the values. You can check it. So what's the answer is Fs is equal to 85.8 Newton, and Fab is going to be equal to 576 Newton, 76 Newton, and Fad is going to be equal to 565 Newton, 65 Newton. So I hope I have enlightened your weekend, and I hope you guys enjoying your weekend. See you next time.